Hello and welcome to my video presentation. My name is Daniella Nottage and I am a primary middle education student. My goal when I graduate is to teach math in high school. Therefore, my planner is based on teaching students in Year 7, knowing I'll be placed in a primary school setting this year for Prof X3.
My unit is linked to the Australian curriculum Year 7 Mathematics. The strand is number and algebra, the substrand is money and financial matters. The descriptor relating to this unit is investigate and calculate best buys with and without digital technologies. The achievement standards for this unit is for students to be able to compare cost of items to make financial decisions. According to Akara, the fluency being developed is investigating best buys, and the problem solving being developed is formulating and solving authentic problems using numbers and interpreting sets of data collected.
The concepts I will be addressing are working mathematically determine what is a best buy by completing mathematical investigations to compare shopping of two different contexts, grocery shopping and mobile phone plans. Students will then have the tools to develop the concept of making financial decisions. Students will be developing deep conceptual and procedural knowledge through thinking and working mathematically. Baroudi, Feil, and Johnson mentioned that mathematical procedures are created to solve a problem, and their steps are worked out according to mathematical principles and logic. Therefore, students will be developing problem solving through solving complex problems by estimating and calculating using efficient mental, written, and digital strategies, and converting common metric units for volume and capacity to solve authentic problems. Baroudi, Feil, and Johnson also mentioned that deep conceptual knowledge depends on knowing the tools for applying and extending mathematical ideas. Therefore, students will be developing reasoning to work strategically to identify and justify best value for money decisions and identify trends using number rules and relationships. Communication will also be developed with students using reasoning, justifying, convincing, and proving best buys for alternate scenarios. This related to Baroudi, Feil, and Johnson regarding deep conceptual knowledge growing as additional connections are made via assimilation and integration.
The unit begins with the first lesson catering towards identifying students' prior knowledge relating to volume and capacity. Vanderbilt mentions how a simple task can be used to activate prior knowledge and be used as a warm-up, which also uses the vocabulary needed for the focus task. Therefore, the students will be recalling their prior knowledge of converting mass and capacity into different units. Firstly, using simple numbers, then using volume and weight references on items purchased from a grocery shop. For example, a can of Milo will show a weight of 400 grams, and students will be required to write this in alternative units such as 4,000 milligrams or 0.4 kilograms. By handling the shop bought items, students may link their thoughts to items that their parents or caregivers buy for their home, establishing a real-life connection. During these activities, anecdotal notes will need to be made to identify student progress at the end of the unit. You will be identifying how students have understood the task and represented their understanding.
New meta-language will be introduced, such as best buys. There will be a discussion asking students what the term implies, particularly after completing the activities. Questions relating to what is best buys or the term best value for money will engage the students to think of purchases that perhaps family members have made that have been a bargain. Students come from varying socio-economic backgrounds, therefore what might be a value for money purchase for one student might be different for another student. As the teacher, you will need to be mindful of this and deliver this unit with equality. Questions will become more directed towards students' understanding of the problem, which is the best value for money. Students will be provided set questions such as these. According to Kamai, word problems such as these encourage students to invent arithmetic out of their own reality, similar to how our ancestors created mathematics out of the necessity of their reality. Kamai also mentions the use of situations in daily living is one way of encouraging children to logico-mathematize reality. Students will discuss how they achieved their problem solving and discuss reasons why. Was there a pattern being developed in how they were working it out?
Closing the lesson, students will be asked engaging questions relating to issues around the concept of best buys. For example, what other factors should we take into consideration when making a purchase decision? Would it be the lifespan of the product is considered, such as expiry of the chocolate milk? Discuss endorsements by supermarkets and other sellers to purchase larger quantities. Example 3 for the price of 2. When should these offers be accepted? When should they be ignored? This will allow students to begin thinking about issues towards making financial decisions.
The second sequence lesson will begin to explore the unit price of items to better understand the concept of best buys. Examples of shops showing unit prices will be shown to provide context to the learning. A link to the ACCC will also be shown to the class to show the validity and reasoning behind the purpose of calculating the unit price of items purchased and why it is important to know this as part of our everyday life. Rees mentions that as teachers we will be required to teach concepts that require us to investigate further because we are unsure. This requires us to explore available resources to assist with building and expanding our content knowledge. Viewing the ACCC website prior to teaching this unit provides information to you as the teacher to be better equipped to teach the topic. The lesson will progress into problem solving, how to calculate a unit price. The students will discuss formats and patterns to establish a solution to calculate a unit price. Scaffolding may be required to help open the problem. This is an example of how to explore and develop a solution to calculate a unit price. Remember to take anecdotal notes from classroom participation and worksheet problem-solving calculations.
The opening of the third lesson will continue with problem solving of unit prices, however this time looking at how unit pricing can be influenced by supermarket brands and recognized brands and how this relates to best buys. This will develop students' ability to make financial decisions. Students will be asked to discuss briefly other purchases where unit pricing can be applied. This will include both products and services. The remainder of this unit will focus on mobile phone use. Students will be introduced to a simple mobile phone cost plan and will explore all of the areas and meta language. The lesson will progress into problem solving, how to calculate a bill using a mobile phone plan. Students will discuss formats and patterns to establish a solution through problem solving and algebraic thinking. Scaffolding may be required to help open the problem. This is an example of a problem. Students will further develop their learning of best buys by identifying, researching, and classifying information from mobile phone providers regarding prepaid and capped plans. There is a YouTube clip of students discussing their personal experiences with this and reasons for their choices. Brochures from mobile phone providers will have an abundance of information on them. It is important to identify and discuss language used on the brochures and develop a greater understanding of what the providers are actually trying to sell. Looking at data, students will be asked questions about what they use on their phone in regards to the data. The lesson will progress into problem solving, how to calculate data charges on a generic mobile phone plan. Students will discuss formats and patterns to establish a solution through problem solving and algebraic thinking. Scaffolding may be required to help open the problem. This is a copy of the average data downloads that can be used to assist in problem solving. Moving forwards, students will estimate the number of web pages, text, emails, etc. they think they might use in 1 month. However, not all students have access to mobiles, tablets, or computers in their own personal lives. Therefore, they will need to have worksheet scenarios ready to hand out. Students will make comparisons of their results to the Best Buy mobile phone plan, establishing financial decisions. By the fifth lesson, students will have a deeper understanding regarding mobile phone plans and applying knowledge gained to find the best buys. Students will be provided scenarios of people needing mobile phone plans and will need to use the information they have learnt to analyze, calculate, refer a mobile phone plan, and prove their conclusion to the class. This coincides with solving problems using efficient mental, written, and digital strategies, working strategically to identify and justify best value for money decisions, using number rules and relationships, and reasoning, justifying, convincing, and proving their decisions. This task will be an individual assessment, both from the completion of the tasks and input in discussing during class. Assessment will be recorded with anecdotal notes and rubric. Feedback will be provided through grading and constructive feedback. The collection of anecdotal notes made from the beginning of the unit will provide information of individual student progress. Students can utilize online activities such as ones available at MoneySmart to extend learning experiences for those who finish early or require an extra challenge. To extend the unit, lessons could include best buys with other living expenses such as weekly groceries, electricity plans, home internet, gas plans, etc., using this information to develop a family budget and comparing household budgets to average income earned and identifying how best buys relates to smarter spending. Through the progressions of the unit, students will be able to work mathematically to determine what is a best buy by completing mathematical investigations to compare shopping of two different contexts, both grocery shopping and mobile phone plans. Students will develop the tools to make sound financial decisions. The sequence lessons provide deep conceptual and procedural knowledge through thinking and working mathematically as a class, in groups, and individually. Students are provided scenarios to estimate and calculate using efficient mental, written, and digital strategies and convert common metric units for volume and capacity to solve authentic problems. Students are given opportunities to work strategically to identify and justify best value for money decisions and identify trends using number rules and relationships. The last sequence has students communicating their reasoning, justifying, convincing, and proving best buys through assimilation and integration. From this unit, students will have the schemes built up to make better financial decisions relating to best buys.